Okay, so for the circular functions, we make use of the abbreviation SO, CA, TOA. So stands for sine theta for the angle equals opposite over hypotenuse. CA means cosine theta equals adjacent over hypotenuse. And lastly, tangent TOA, tangent theta equals opposite over adjacent. For example, this is your right triangle drawn on a unit circle. So again, we have here 1, negative 1, negative 1, and 1. So we'll have sine theta. For example, this is the angle theta is opposite over hypotenuse. So opposite this is y because it's vertical. So we'll write y instead of the opposite. It's right here y. And then the hypotenuse is actually equal to 1 because that is the radius. So hypotenuse is equal to 1, meaning sine theta is equal to y over 1, or simply this is equal to y. Okay, next we have cosine theta, that is adjacent. So here's theta and this is the adjacent side. Horizontal meaning that is x. So adjacent is x. And again, hypotenuse is the longest side, which is the radius here, that is 1. So we have over 1. Okay, and then this can be simplified as x. Again, sine theta is y, cosine theta is x. Lastly, opposite over adjacent, that is for tangent theta. Theta, opposite is y, adjacent is x. So we write here y over x. Again, remember we have the abbreviation, so CA, TOA. Alright, so for example, we need to find cosine of 240 degrees. We have cos 240 degrees. So we draw first the angle here, starting from the initial side. So we have here 90, 180, and 240. Okay, say for example, this is the point of intersection. Let's put an arrowhead. So again, this is positive 240 degrees. First step is to find the reference angle. So we'll find the reference angle. Since it's in quadrant 3, the reference angle would be this part. So to show the solution, that would be 240 degrees minus 180 degrees. Again, this is in quadrant 3. Alright, so the answer is 60 degrees. Therefore, we need to find the coordinates of 60 degrees. Now recall that the coordinates of a point, or the point of intersection of the terminal side on the unit circle of 60-degree angle is, or are, the coordinates are 1/2 and square root of 3 over 2. Now, this time, 240 degrees has reference angle of 60 degrees and it is located at the third quadrant. So cosine 240, remember that cosine theta is x. Alright, and x here is 1/2. But since the location is on the third quadrant, here we have negative and negative. Therefore, the answer is negative 1/2. Okay, this time let's find the sine 690 degrees. So we have to draw the angle again. So we start with the initial side at the positive x-axis. A complete revolution is 360 plus 90, 450 plus 90 is 540 until we reach 690 degrees. Notice that the location is at the fourth quadrant. So the signs here will be positive for x-axis and negative for y-axis. Sine 690 degrees, so we need to find first the reference angle, and that is this part. Alright, so how do we measure the reference angle? Alright, since it's greater than 360 degrees, we use the step-by-step solution. So we need to find first the coterminal angle of 690 degrees, or a smaller coterminal angle. So this is 690 minus 360 degrees, which gives us 330 degrees. And 330 degrees is, of course, in the fourth quadrant. So we need to find the reference angle of 330, this part, meaning that is 360 degrees minus 330 degrees. Again, the first one is the coterminal angle, because this is greater than 360 degrees. And then the next one, we are looking for the reference angle. So 360 minus 330 is 30 degrees. The reference angle of 690 is 30 degrees. So recall the coordinates of point of intersection of a 30-degree angle in a unit circle. That is square root of 3 over 2 and 1/2. Alright, so let's go back to the definition of sine. Sine theta is actually y. So y here is 1/2. And since it's in the fourth quadrant, y is negative. Therefore, sine of 690 degrees is negative 1/2. Okay, let's proceed with the next example. We have the value of secant negative 405 degrees. So we put open and close parentheses for negative angle measures. So we'll graph first. Since it's negative, the rotation is clockwise. So from the initial side, go down. So this is 360 and 405. Okay. Alright, so this is negative 405 degrees. Just like the first two examples, we need to find first the reference angle. And since it's in the fourth quadrant, the signs are positive and negative. The reference angle will be this part. Alright, so let's take a shortcut. Let's disregard the negative on the given, that is 405 minus 360. We take the excess, so that is 45 degrees. The reference angle is 45 degrees, and the point 45 degrees, or the point of intersection of angle 45 degrees in the Cartesian plane or the unit circle, coordinates are square root of 2 over 2 and square root of 2 over 2. Since you would like to get the value of secant, remember that secant is the reciprocal of cosine. So we have 1 over x. Therefore, we write 1 over x here is square root of 2 over 2. Let's check the sign. Positive. So 1 over square root of 2 over 2. Okay, let's simplify. This is 1 times square root of 2 over 2. Get the reciprocal. So this becomes 1 times 2 over square root of 2. 1 times 2 is 2, and then over square root of 2. Okay, we rationalize because the denominator is a radical. So we have times square root of 2 over square root of 2, because this is also equal to 1. Alright, 2 square root of 2 over square root of 2 times square root of 2 is square root of 4 or 2. And we may cancel this because 2 divided by 2 is 1. So final answer is square root of 2. Secant of negative 405 degrees is equal to square root of